We have already discussed the measures of skewness and kurtosis of binomial distribution. In the measure of skewness, we found that when q is greater than p, the frequency curve of binomial distribution is positively skewed, and if q is less than p, the measure of skewness will be negative and the frequency curve will be negatively skewed. At the same time, when q is equal to p and is also equal to 0.5, the frequency curve will be symmetric because gamma 1 will be 0 when q equals p equals 0.5. Apart from this q equals p equals 0.5, the frequency curve will also become symmetric when the number of trials n becomes large. Now we can verify this concept with the help of frequency curve drawn for different values of n and p. In the first slide, we take n number of trials as 10 and the probability of success p as 0.9. That is, x follows binomial 10, 0.9. So when p is 0.9, clearly q will be 0.1, where q is less than p and the frequency curve will be negatively skewed. That's why very less probability at the initial values of x. At 0, it has probability only 10 raised to minus 10 into 1. And at 1, it is 10 raised to minus 9 into 9.0. And the probability becomes maximum at 9. And at 9, the probability is 0.387420. So this is the situation when q is less than p. In the next slide also, we take q as less than p. q is 0.2 and p is 0.8, that is, x follows binomial 10, 0.8. Here also we get the value of gamma 1 as negative since q is less than p. And the probabilities at various values are given in this table. At 0 again negligible, and at 8 the frequency curve attains the maximum probability. Next we try with another pair of n and p. Here n is 10 and p equals 0.7. Even now the value of q is smaller than value of q is smaller than value of p. q is only 0.3 and p is 0.7. Then also the frequency curve will be negative. Here highest probability is occurring at 7. We can also verify this highest probability occurring point by considering the mode of binomial distribution. We will discuss the mode of binomial distribution in another section. Now next is x follows binomial 10, 0.6. Here also the value of p is 0.6, which is greater than the value of q is only 0.4, and then also the frequency curve becomes negatively skewed. So whenever q is less than p, the value of gamma 1, that is q minus p by root n pq, we found in the measure of skewness will be negative, and therefore the frequency curve is negatively skewed. But when q is equal to p and that equal in common value 0.5, the curve will be symmetric. It is very much visible in the graph. You can see at x equal to 5, that is the highest probability, and towards the left and right, there is a very beautiful and symmetric probabilities. At 4 and 6, same probability. At 3 and 7, same probability. 2 and 8, same probability. And also at 1 and 9, same probability. 0 and 10, same probability. So the curve is very beautiful symmetric shape attains when p is 0.5. Now when this value of p is 0.4 and q becomes 0.6, q becomes greater than p and the shape becomes positively skewed. And next graph we see that q is 0.7 and p is 0.3, the shape becomes positively skewed. In that manner, whenever q is greater than p, the gamma 1 value will be positive and the frequency curve becomes positively skewed. Apart from the common value of q and p 0.5, the frequency curve also attains symmetric shape when n becomes large. Again, this can be illustrated with the help of changing values of n. Now we take n as 5 and p as 0.15. So this is the shape of the frequency curve, and it is very clear. Q is 0.85 and P is 0.15, so it is positive, it is Q. And we take then n as 10 and P equals 0.15. Now next n is 20 and P is equal to 0.15. Now n is 40, 0.15. We are increasing the values of n, and therefore the shape of the frequency curve becomes slowly symmetric. This is the situation when n equals 70 and p equals 0.15. And this is the situation when n equals 100 and p equals 0.15. The shape is very symmetric. And now this is the shape when n equals 170 and p equals 0.15. So almost at n 170, the shape is very symmetric, or it is similar to the shape of normal distribution. That's why we say binomial distribution can be considered as a distribution which will be attracted to normal distribution when n becomes large.